Hello learners, welcome to Triaright. Today we will be learning for the Armstrong number, a program that will be providing us for the Armstrong number using the functional interface. So here we will first getting to know what is an Armstrong number. So here we have the three-digit number 153, which is a three-digit number. If we will be cubing is three-digit number, so if we will be cubing the number, cubing the number. So cubing means the number of digits. Number of digits here there are three digits, so we'll be cubing it. So cubing each digits and providing the summation of all those cubes, we'll be having 153 only. And coming further, we have this 9474. So it consists of four number only. Now we will having the fourth power of each and every digit. Now suppose here we have 9, so we'll be putting the fourth power on it, and for the 4 also we'll be putting the fourth power, and 7 also, and 4 also. Now when we will be doing summation of all those number, means when we'll be adding all those number, finally putting the powers and adding all those number, it will be giving that number only. So it is an Armstrong number. Now coming on to the definition, the Armstrong number is a number that is equal to the sum of own digits, each raised to the power of the number of digits. Each raised to the power of number of digits means the number of, as here there are three digits, so we'll be giving it here there are four digits, so we'll be having fourth power of it, fourth power of each and every digit, and when summation is done, that will be adding up to the same number only. So it's an Armstrong number. Now coming on to the programming part of this program. Yeah. So in the beginning we have to write add the rate of functional interface, because we are doing it with the rate of functional interface. We are doing it with the help of functional interface. So add the rate of functional interface, and after that we have this interface. There is an interface Armstrong checker, which has a method, inside it, which is not having any body part. And similarly, the method has also return type here. The boolean is a return type of this method. Each Armstrong is the method here. Each Armstrong is the method, and here integer int number. Int number is the parameter of that method. Yeah. So here we are having a functional interface. This functional interface is having only, this is just look like class, but it's not a class. Here it will look like class, but it's not. It is not a class. Here it will not have any body part. It will not have any body part. And coming in here, this method here, it will contain a method. This interface will contain a method which will not have any body part. Yeah, it's not having a body part. Now coming on to this class Armstrong number printer. Armstrong number printer. There is a class Armstrong number printer having the public static void when string asks as the main method line. Now following that, we have the lambda expression for that Armstrong number logic. For here we will have Armstrong number checker with the variable checker. Here we have Armstrong number checker. This interface Armstrong number checker, Armstrong checker with the checker variable, and here the parameter. So it states that parameter is given by the numbers. Parameter, that's the number. It will state the body part. It will go up to the body part. Here for the lambda expression, we have the parameters that will be going up to the body part, and here coming in this body part, we have the int original. We are assigning the number as we will be assigning these numbers that will be provided here to that original as the variable here. Now coming further, we have int digit that's equal to count digit numbers. It will be counting the digit number. This is a method. Int count digit numbers is a method that will be counting the number of digits. And now coming further, we have int sum is equal to 0. There will be taking a summation value, that variable that will be assigning to 0. And similarly, we will be having a temporary variable temp equals number that will be assigned with the number. Number which we are taking here. Now, while that temp is greater than 0, while this temp variable is greater than 0, int digit temp variable is 0 to 0, and coming to this body part of this while loop, we will have int digit is equal to temp mod 10. We will be extracting the last digit of that number. By temp mod 10 temp mod 10, we will be extracting the last digit from the number. That will be given to this digit, and summation plus math.pow. This is a method. This is a method for putting the power of that number. That will be now, that digit will be given to that digit, and to that we will be giving the digit and number of digits in that number, to that number of digits in that number. Here we are taking it here. So we can see here that we are finding the how many numbers are there, how many number of digits in that number, how many number digit is that number containing. So here we will be finding the number of digits in that number by this method, count digits. By this method we will find the number of digits in that number, and we will be putting the here, and this is the digit that we will be taking out, from the end, single digit. That single digit having the power of the digits, and that will be added to the sum part, which is having initially 0 value. Now when we have done that with that number, we will remove that number. For that we will be doing temporary by temp. For that we will be doing temporary by 10. Finally we will be returning we will return sum is equal to original. We will be returning the sum equals original. If that number is equal to original, that number is equal to original, that will return. And finally we coming on to the end, we will printed system.out.println Armstrong will be printing Armstrong number from 1 to 1000. Now here we will be printing 1 to 1000. For that, here the statement will be printed here, and for that we will be taking a loop from counting 1 to 1000. We will be taking a loop, and if in the body part we will be writing if checker.armstrong. Checker is the variable and is Armstrong is the method. Yeah. And for this I number, for this, all the numbers from 1 to 1000, all the numbers will be from 1000. Every number will be checked here, with the help of if checker is Armstrong, and that will be provided with in parenthesis. We will providing I as the point for checking that Armstrong number or not. And finally, if it is an Armstrong, system.out.println of I for that Armstrong number or not. Yeah. So here each and every one will be checked and return the similar value. I repeat, coming to the beginning, we have seen what an Armstrong number is. Armstrong number, if there is a number, total number of digits as 3, we will be cubing each digit. If the number is 4, if total number is 4, we will be putting fourth power of each and every digit, and summation of all those 14 the power we will do summation, and at the end of summation of that number, that will be adding up to the number only. So here we are doing with the help of functional interface. So in the beginning, the first line will be at the rate of functional interface. That is an annotation, and after that we are using interface. Here we providing that interface as Armstrong checker, and boolean is Armstrong is the method. Here this is a method which is having no body part, and there is an int number which is a parameter being passed to it. Now coming here, we have the public class Armstrong number. We have the class Armstrong number checker having a main method line, and following to that we have the lambda expression for finding the number is Armstrong or not. For Armstrong checker, we have used that Armstrong checker as the interface. So we are taking checker as a variable, and this variable is of type Armstrong checker, and to this variable we will be providing a number. We will be providing that this number having the body part. Yeah, it is having the body part, and this body part here it will be first we will be providing int original is equal to number. That number will be given to that original number, and that variable will be having the number only. And coming further, we will have that digit. We will be counting the number of digits in that number, and then we will be providing the summation as 0 part only, and then we will be putting int temp. We will giving the temp. We will be taking a temp variable, and we will be giving these numbers to this temp variable. Then we will be giving this numbers to temp variable, and while the temp is greater than 0, while the temporary variable what we have given the temporary variable that is greater than 0, until and unless this body part will be found. Here in coming to this body, in digit, first we were taking the last digit from the number by providing int digit temporary mod 10. Mod 10 will provide us the last digit from the number, and providing the last numbers, providing the last digit from number, we will be coming to sum summation sum plus mat.power. This is a internal method for powering the number, and here we will provide the digit, that is the last number, and the number of digits in that number, that is the digits. Here mat.power, to that mat.power we will provide the digit that we have taken from the last n mod 10, the last digit, and to the power we will provide the number of digits, total number of digits. Yeah, by this method we are using the digits is equal to count digits number, and then we will be reducing the finally when we are done with that part only, then we will be extracting that number, we will be removing that number. So for that we have to do temp by is equal to 10. For that we will be dividing the number by 10. That will remove that digit from there. Yeah, now coming on to this part, then we will be closing the brace, and after that we will be writing sum equals to, if the sum number is equal to origin, that number will be returned. And for that, after that we will coming out of the loop again, and finally we will be printing system. We will be printing Armstrong number between 1 to 1000, 10,000. Yeah, sorry, 1 to 10,000. And for that we will be generating a loop from 1 to 10,000, and in the loop we will be checking if checker dot is Armstrong. If checker is a variable, and Armstrong is a method where we are providing each and every digit, and we're checking if the provided digit is an Armstrong, then it will be that system then that number will be printed here, then that number will be printed, and coming further we will be getting the output also. So here we have a helper method to count number of digits. So there we have digits is equal to digit int number. Yeah, that is digits equal to count digits. Yeah, digits int digit, we have taken int digit is equal to int digits is equal to count digit. That is a helper method that will be helping the number of that will be helping the number of digits in that number. For that digits number, for that digits we will be writing the functional part here. For here we have the method count digits is the method which will be provided to int number. If number equals 0, then that number will be returned, then that number will be returned by -1. Number will be 0, then we'll be returning 1. Yeah, now int count, we will taking int count variable, and we will be assigning it with 0, and while that number is greater than 0, and we will be first counting plus, we will be counting plus. So in the beginning the count was 0, and for the first time coming in the loop, we will be first taking the numbers, and we will be counting that it will be count plus, and after that we will be removing the last numbers. We will be removing that last number. After that it will be again greater than equal to 0 or is equal to 0. Suppose if it is greater than 0, then again the count plus will be done, and again the number will be divided by 10. This the last number will be removed from that. Similarly producing each and every things like till the end. Then finally at the end we will return count. We will be returning that count value to find the number of digits in that number. Yeah. So for 1 to 10,000 we will be getting the output as 1 to these numbers. These are Armstrong number. These are all as Armstrong number. Yeah. So coming here, finally moving on to the end part, we will be watching that is Armstrong number. We are able to watch that Armstrong number functional interface. We have seen the Armstrong number functional interface defines a method Armstrong in number, where to this is Armstrong method. We are providing a number which we are checking for that is this number Armstrong or not. And for that we have the lambda expression also. If we check for the number is Armstrong number, if this lambda expression we check for the number is Armstrong or not. Now finally we were running from the method for providing the numbers from 1 to 10,000, and we are checking the condition, and that satisfies the condition and numbers, and then we are checking the number for 1 to 10,000, and for each and every number we will be providing for against different methods to check whether that number is Armstrong or not. And finally, we will set and finally the condition that satisfies the numbers that this is our Armstrong number, so that those numbers will be printed here. Now we are at the end of the class. We'll meet in the next class. Now thanks.